Alright, welcome to today's video. We're going to be talking about introducing rates. And you've probably noticed we've been going from fractions into percentages, and then percentages into ratios, and now ratios into rates. And they're all kind of related. One sort of, well, they don't really follow each other. They're all sort of in the whole big mixed bag. And rates has a lot of application in real life, and especially in the sciences. Physics is a big one for me, and so I'll show you a couple of the physics ideas of where rates is used. So for example, we have here that energy is 1 joule, and 1 joule is equal to 1 kilogram meters squared per second squared. But we sort of make that just a joule instead. Force, which is a newton, is equal to 1 kilogram meter per second squared. And power, which is a watt, is equal to 1 joule per second. And potential difference, like electrical energy is 1 volt is equal to 1 kilogram meters squared per second cube amps, or 1 joules per coulomb, or 1 volt is probably the easiest way to do it. But a couple of key ideas to sort of talk about our rates. Right. Rates compare quantities that are different units, so they must include the units, okay? So when we're talking about rates, we have to have units, so must. All right, you can't have rates without the units, got to be in there. The units are separated by a slash, which means per, and there's really common ones like kilometers an hour, or here we got 16.7 m/s, which is equal to 16.7 meters per second, m/s, okay? Now, similar to fractions and ratios, you should represent your rates in their simplest forms. For example, the car traveled 36 kilometers in 4 hours. And the simplest form for that is we look at both of these, and they both have a highest common factor of 4. So we divide by 4 and divide by 4. So the simplest way of doing that is 9 kilometers in 1 hour. Okay, so they mean exactly the same thing, because as per our percentages and fractions and ratios and things, we've done the same thing to kind of both sides of the rate. All right. Now you can calculate the average rate by dividing the total change in one quantity by the total change in the other quantity. So, for example, I drove 600 kilometers in 4 days. Well, the average rate, we divide 4 by 4 to get 1, and we divide 600 kilometers by 4 to get 150 kilometers in a day. Therefore, the average rate is 150 kilometers per day. Okay, so that's how we do the average rate sort of problems. Right, a couple of quick examples. Okay, example number 1, express 1500 kilometers per 30 hours in its simplest form. So, first off, we want to write 1500 kilometers per 30 hours. Well, when you're doing simplest form, you're trying to get one of them down to 1, all right? But let's do it sort of properly, and we'll have a look. Highest common factor of 1530 is 30. I've chosen these particularly well, so that they'll work straight away. Many of the questions you do out of the text in an exam format will be chosen particularly so that they will kind of work, although you do have calculators, so it will be very easy. Right, so we're going to divide 30 by 30, and we're going to divide 1500 by 30, and that's going to get us 50 kilometers per hour. 50 kilometers per 1 hour is the simplest form of the 1500 kilometers per 30 hours. Okay, right, another one. This is a legit record. Sam Stilson holds a record for crushing 56 eggs against his head in 30 seconds. How many eggs would you expect Sam to crush in 5 minutes? So let's sort of set this up. We start off with going 56 eggs per 30 seconds. Okay, now the first thing we want to do is we want to go from seconds to minutes. Okay, because we want our first, we're looking for a final answer in per minute. So we want to go from seconds to minutes, and the way that we'll do that is there's 60 seconds in a minute. So we're going to multiply both of these by 2. Okay, and so that gets us per 1 minute, and 56 times 2 is 112 eggs per 1 minute. Okay, so we've gone from seconds to minutes because our final answer is looking to be in minutes. So next we're going to go from 1 minute up to 5 minutes. Okay, so we will multiply this side by 5 to get from 1 minute to 5 minutes. So that means we have to multiply this side of the rate by 5. And we end up with 560 eggs per 5 minutes. Okay, so you might want to answer this at the end with Sam should crush 560 eggs in 5 minutes. Okay, right, another ridiculous record actually taken from the Guinness World Records website. The record for the most wooden toilet seats broken with the head in a minute is 46, achieved by Kevin Shelley from the USA on the set of the Guinness World Records Die Großen Weltrekorder in Köln, Germany on 1st September 2007. What a great guy. Calculate the average toilet seats broken per minute. So here we're going from a rate that we know, 46 per minute. Now we want to go for an average toilet seats broken per second. Okay, so 46 seats per 1 minute. Okay, and we have 60 seconds per minute. So we need to multiply both sides by 60. Okay, and so that brings up per second. And 46 times, hang on, not times by 60. That means it's getting faster. We want to divide by 60. This is where it helps to think about your ratio problems, because it's not always going to be exactly the same thing you're doing. So okay, I'll tell you what, I'll show you a better second step to avoid that problem. Right, so 60 seconds in a minute, so we can do instead 46 seats per 60 seconds. Okay, we haven't changed anything really, we've just changed units from minutes to seconds, okay? So then we need to go to every second. So to get from 60 seconds to 1 second, we're going to divide by 60. That means we need to divide this side by 60. Okay, so for these problems, it does involve a little bit more reasoning than purely doing this one particular process all the time. So now we know that we are in per second, per 1 second, and 46 divided by 60 is 0.77 recurring seats. So, what was his name? Kevin Kevin breaks 0.77 seats per second. And what a ridiculous record. Right, that's a quick little intro into dealing with rates. If you're familiar with how we work with ratios, the rate stuff should be quite easy for you. So I encourage you to maybe try some of the examples or some similar things from the text and come to class with any extra questions that you have. Thanks for watching.